ABCD is a rectangle and PQRS are the midpoints of side AB, BC, CD and AD respectively. Show that the quadrilateral PQRS is a rhombus. So I want you guys to draw the diagram. Think about what is given and what is that we need to prove. Okay, so we are looking at a rectangle. So how does a rectangle look? What are the properties? Think about the sides first and then the angles and then the diagonals. So list the properties one by one. So we have AB, CD. So these are the midpoints. So if we happen to join this, it becomes a rhombus. So I want you guys to figure out all the properties. You can open your previously written things. You can open any resource. I want you guys to recall the properties: side, angle, and then diagonal. In this order, I want you guys to recall. Okay. So ABCD is a rectangle. So what are the properties? So let's kind of make a list of it. Given ABCD is rectangle. So here opposite sides are equal and parallel. Okay. Then what else we have? We can also tell that the corners are 90 degrees. That is about the angles. And all the angles are equal by default. And about diagonals, they intersect at an angle of 90 degree. Sorry. They bisect each other. They don't intersect at 90 degree, they bisect each other. That's about diagonals. Now, P, Q, R, S are midpoints of AB, BC, CD and AD. Show that quadrilateral PQRS is a rhombus. So we need to prove that this is a rhombus. So how do we do that? To prove PQRS is a rhombus. So what's special about rhombus? Well, let's list one by one. First is the sides. All the sides are equal and they're supposed to be parallel to the opposite sides. Next, about angles, opposite angles are equal. And about diagonals, the diagonals intersect each other at an angle of 90 degree. So if I join this and join this, so they intersect each other at an angle of 90 degree. So now figure out how do we prove this. So you guys know the properties. I've listed the properties. So prove that all the angles are equal and that diagonals meet each other at 90 degree. Okay, so how do we go about doing this? Well, we know that diagonals of a rectangle are equal, so we can call them as 2x. Okay, and that's your clue. Diagonals of a rectangle are equal. So let me begin. Proof. So we'll tell AC is equal to DB, and the reason being diagonals of ABCD, which is a rectangle. So we'll call them as, let them be equal to 2x. You'll see why in time. Now we'll consider triangle ABC. A, B, C. P, Q are midpoints of AB and BC respectively. So we can conclude that PQ is parallel to AS and PQ is half of AS, so they will be equal to X. So half of AS, they will be equal to X. The reason being midpoint theorem. Okay, so we proved that this is X. Then we can tell similarly in triangle ADC, as S and R are midpoints. So we have AC parallel to SR and SR being equal to half of AC. Okay, I've written AS. AC by 2. So this is equal to X. Okay. Now, what else can we tell? So we can tell from 1 and 2. So we have SQ being equal to SR and also parallel. So this becomes a parallelogram. So how does a parallelogram become a rhombus? Sorry. If I prove that adjacent sides are equal, we are done. So let me first conclude this. Okay, we can do that later. So as of now, in our hand, we have this to be parallel and equal. So this makes it a rectangle. Sorry, parallelogram. To prove that it's a rhombus, we have to prove that adjacent sides are equal. For that, we need to join BD. Okay, and give the same reason. So we'll tell again similarly in triangle ADB, as S and P are midpoints of AD, comma AB. We'll also write it over here, AD, comma DC. So what can we tell? Since these are the midpoints of AD and DB, SP is parallel to DB and SP is half of DB, which is equal to X. So from all of this, what can you conclude? So from equation 1, we'll call this as 1, this entire thing as 2, and this entire thing as 3. Okay, so we can tell that consider quadrilateral PQRS as opposite side. Which other side? PQ is equal to SR and PQ being equal to SR and PQ being parallel to SR. What can we imply? PQRS is a parallelogram but SP is equal to PQ, thus PQRS can be considered to be rhombus. Reason, as all sides are equal, is it not? Since in parallelogram opposite sides are equal, so here we just prove that adjacent sides are equal. Okay, so we can write that actually adjacent sides are equal. That will be a bit more better, as adjacent sides are equal right? So we can call this as rhombus. That's it. So me talking about 90 degree, where did I do that? I didn't. So diagonal meeting at 90 degree is not required over here. We proved it by talking about all the sides being equal and parallel because it's a parallelogram, right? So this is your answer.